Welcome to TipsKnowLogy. This is day 5 of our microcontroller tutorial. Let's start. Time delay. There are two ways to create a time delay in 8051C language. The first way is by using the 8051 timer. The second way is by using a simple for loop. There are three factors that can affect the accuracy of the delay. The first factor is the 8051 design. These include the number of machine cycle and the number of clock periods per machine cycle. The second factor is the crystal frequency connected to the X1 and X2 input pins. And the third factor is compiler choice. The C compiler converts the C statements and functions into assembly language instructions. And remember, different compilers produce different codes. Example: write an 8051C program to toggle bits of P1 continuously, forever with some delay. As you can see in the solution, the first two lines begin with // These are just comments about the program, and is not really necessary. Lines of code, line 3, 4, and 5, are the usual things that we put in the program. Unsigned int x declares an integer variable named x. For open parenthesis, semicolon, open parenthesis, means that whatever is between its curly brackets will be repeated forever. So, from P1 equals 0x55 semicolon, up to the statement for open parenthesis x equals 0 semicolon x less than 40,000 semicolon x plus plus open parenthesis semicolon will be repeated forever. In this example, we need to write an 8051 degrees Celsius program to toggle bits of P1 ports continuously with 250 milliseconds. In the solution, the statement void ms delay open parenthesis unsigned int I time close parenthesis semicolon is declaring a user-defined function ms delay that will pass an integer and will take an integer to the variable I time. The contents of this function is found after the main function. Look at the bottom of the main function. On the other hand, inside the main function, there is a repeat forever statement, the while open parenthesis 1 close parenthesis. Whatever is inside this while 1 statement will be repeated forever. So, the four statements starting from P1 equals 55 semicolon up to ms delay 250 will be repeated continuously. Port P1 equals 0x55 semicolon means P1.0, P1.1, P1.2 until P1 will have the values 0101, 0101. This is because hexadecimal number 5 equals 0101. Then, the user-defined function ms delay is called, or will execute, or run. The integer number 250, on the other hand, will be passed or transferred to the integer variable I time. So, two things will happen here. First, the function msDelay will run, and the number 250 is passed to the variable int. As you can see at the bottom of the main function, the msDelay function will have a value of 250 for its iTime variable. It will also declare two integer variables, letter I and letter J. Then, the two for statements will make the value of I between 0 up to less than iTime, increasing by 1. This means I will be from 0 up to 249. 249 because the limit is less than 250. You will also see that the next for statement will make the value of j to be from 0 up to less than 1275, that is, 1274, and is increasing by 1. In other words, I will be counting from 0 to 249, but it will only increase by 1 after the variable j has counted from 0 until 1274. Actually, the msDelay function is approximately equal to 1 millisecond delay. So, by putting msDelay 250 to it, it will become 250 milliseconds of delay. Meaning, if 150 milliseconds of delay is needed, we can make this statement msDelay open parenthesis 150 close parenthesis semicolon, depending on the given delay required by a particular problem. In this problem, a 250 milliseconds delay was required. That's why the msDelay statement has 250. Now, let us talk about input-output I/O programming. In particular, let us discuss byte size I/O. In this problem, LEDs are connected to bits P1 and P2. Write an 8051C program that shows the count from hexadecimal number 0 to FF on the light-emitting diodes, LEDs. By the way, the hexadecimal number 0 is equal to 0000, and the hexadecimal number F is equal to the binary numbers 1111. So, the hexadecimal numbers 0 to FF is equal to 0000, 0000 to 1111, 1111 in binary. This is assuming that we are having 8 digits. 00 to FF equals 8 zeros up to 8 ones. In the solution, #define LED P2 semicolon is defining LED as P2. This means, if you want to use P2, you may write LED. So, LED is the same as P2. Inside the main function, P1 equals 0, 0 means that port 1 will be used as an output port. Aside from clearing P1, LED equals 0 means the same port 2 will be used as an output port. This is besides clearing it. The for statement with the 2 semicolons means the 2 statements inside it will be repeated forever. These 2 statements to be repeated forever are P1++, which means it will be incremented or increased by 1. In other words, it is the same as P1 equals P1 plus 1. Similarly, LED plus plus also means the same. It will be increased by 1, or 1 is added to LED variable, or LED equals LED plus 1. If you still don't understand, the ports P1 and P2 will have the values from 0000, 0000 until 1111, 1111. And this is exactly what is required in the problem. In this problem, we need to write an 8051C program to get a byte of data from P1, wait 1/2 second, and then send it to P2. In the solution, the statement void ms_delay open parenthesis unsigned int I time close parenthesis semicolon is declaring a user-defined function ms_delay that will pass an integer and will take an integer to the variable I time. The contents of this function must be included in the program after the main function, or at the bottom of the main function. You will see this function after main has finished. Now, inside the main function, a character data type variable, myByte, is declared. Then, port P1 is made to be an input port. Take note that 0 means output, while 1 means input. That's why P1 equals 0xFF means all of the 8 pins of port P1 will have the values of 1111, 1111. This means P1.0 up to P1.7 will become input ports. Inside the while 1 statement, the 3 statements will be repeated forever. Let us see what these 3 statements are doing. myByte equals P1 will be making the character variable myByte to become equal to P1. So, whatever is in port P1 will be assigned to the character variable myByte. Take note that P1 was made to become an input port, so whatever values are in its pins P1.0 to P1.7 will be going to myByte variable. Let us say P1 is 1100, 1110. This means myByte will also be 1100, 1110. In hexadecimal, this is CE. In other words, the value of myByte depends on the value of all of the pins of port P1. On the next line, ms_delay 500 will do 2 things. It will call the user-defined function md_delay, and at the same time, it will be giving the integer value 500 to the integer variable I time of the ms_delay function. Again, as discussed before, this will create a 500 milliseconds delay. On the next line, P2 equals myByte will make the value of P2 to become equal to whatever is in myByte character variable. So, if myByte has 1100, 1110, then port P2, starting from P2.0 up to P2.7, will have the same value of 1100, 1110. In this next example, we need to write an 8051C program to get a byte of data from P0 if it is less than 100. Send it to P1, otherwise, send it to P2. In the solution, my byte, again, was declared as a character variable. P0 equals 0x, ff, means that P0 will have a value of 11111111. This will do two things. It will assign 11111111 to P0, and it will make it an input port. The statements inside the while one function, as mentioned before, will be repeated continuously, or will be repeated forever. My byte equals P0 will make the value of my byte to become equal to whatever is in P0. Which means, if P0 is 11000101, which is C5 in hexadecimal, then my byte will also be the same, 11000101, which is C5 in hexadecimal. If the value of my byte is less than 100, port P1 will become equal to the value of my byte. Else, port P2 will be equal to the value of my byte. In other words, 8 bits, or 1 byte, of data coming from port P0 goes to my byte variable, then goes to either port P1 if it is less than 100, otherwise goes to P2, as given in the problem. So the problem is solved. Now, let's talk about a problem that will require us to write an 8051C program to toggle all of the bits of P0, P1, and P2 continuously with 250 milliseconds delay. Use the SFR keyword to declare the port addresses. In the solution, / means this line is just a comment and is not necessary in the program, but it is a good way to tell what the program is doing. That is, this program will access ports as special function registers, SFR, using the special function register, SFR, data type. SFR P0 equals 0x80 semicolon assigns 10000000 to port P0. SFR P1 equals 0x90 semicolon assigns 1001 0000 to port P1. SFR P2 equals 0x80 semicolon assigns 1010 0000 to port P2. All of these are the SFR keywords to declare the port addresses. Take note that another way to access or use the SFR RAM space 80 to FFH is to use the SFR data type. Again, the letters SFR is used here as a data type, just like any other data types. The following statements will be repeated continuously or forever. Ports P0, P1, and P2 will have the hexadecimal value 55. This will actually assign 0101 0101 to these ports. Then, there will be a 250 milliseconds delay. This will be because of the function msDelay250. Again, this user-defined function will do two things. Call the function ms delay to run, and give the value of 250 to the integer variable time, which is found in the function ms delay. Then, all of the three ports, P0, P1, and P2, will have the hexadecimal value AA. Take note that A in hexadecimal is equal to decimal 10, which is 1010 in binary. So, this will actually assign 1010, 1010 to these three ports. Then, again, there will be a 250 milliseconds delay. So, to make things more easy to understand, from 0101, 0101, the values of the three ports will be 1010, 1010. That's why this is called toggle. 1 will be 0, and 0 will be 1. Let us continue the discussion about input-output programming. Let us talk about accessing or using special function register SFR addresses, that is, from hexadecimal number 80 to FF. Let us write an 8051C program that will turn the bit on port P1.5 on and off 50,000 times. In the solution, there is no hashtag include reg51.h. This let us use or access any byte of the SFR RAM space hexadecimal number 80 until FF. This is widely used in new generation of 8051 microcontrollers. Going back to the program, the variable myBit, written in capital letters, is declared as a single bit, S-bit, and was assigned hexadecimal 95. Take note that 95 is equal to 1001, 0101. This is the bit address between 80 to FF that we wanted to use. This time, we are only using a single bit of SFR by writing the particular bit address, that is, hexadecimal number 95. Then, inside main, an unsigned integer variable, z, was declared. Then, there is a for statement that will repeat 50,000 times, that is, z will be 0 up to less than 50,000. Remember that less than 50,000 is 49,999. So, 0 to 49,999 is 50,000 times. MyBit equals 1, and MyBit equals 0 will be repeated 50,000 times. In our last topic for Day 5 microcontroller tutorial, we need to write an 8051C program to get the status of bit P1.0, save it, and send it to P2.7 continuously. Here, we will be using the bit data type for the bit addressable RAM. In the solution, inBit was declared as an S-bit and was assigned as port 1.0. Take note that we don't write period or point. Instead, we use the caret symbol. OutBit was declared also as a single bit SBIT to represent port P2.7. Again, be careful in writing the caret symbol. Then, the variable memBit is declared as a bit we use the bit data type to use or access data in a bit addressable section of the data RAM space from 20 up to 2F, written in hexadecimal. Two statements inside the main function will be repeated forever. Membit will be equal to in bit. Remember that in bit is also the same as P1.0. So, membit will be equal to P1.0. Then, outbit will be equal to membit, or, which is also P2.7. These two will be repeated forever. Membit equals inbit, and outbit equals membit. That's the end of day 5 in our microcontroller tutorial. Please subscribe, like, share and click the notification bell for the next tutorials. See you again, here in TipsKnowLogy. Thank you, and goodbye.